All right, so we want to go into simultaneous equation, but this time around, I want to solve it using matrix method. Please, before we begin, there's something we must know: how to find determinants. There are two ways of solving simultaneous equation using matrix method. You have the inverse method, you have the Cramer's rule. We're going to start with understanding the Cramer's rule because that is very, very simple for many students to catch up. So please follow up. This is the two ways of dealing with simultaneous equation. Now, how do we find the determinants? Determinants of that matrix there, you have 4, 6, minus 1, 2. So if you are going to find determinants, you're going to do the main diagonal products of main diagonal minus products of the other diagonal. So the main diagonal I'm taking here is the one this way. That's the main diagonal. So that we have 4 times 2 minus 6 times minus 1. That is how you find your determinants. 4 times 2 is 8, minus 6 times minus 1 is minus 6. Minus and minus is plus, plus 6, that gives you 14. Very simple and very clear. You try this. 3 minus 2, 4, 9. Try it and give me your answer. 1804 minus 3. Try it and give me your answer for the determinants. So if you have done this, let's check. 9 times 3, main diagonal, minus 4 times minus 2. 9 times 3 gives me 27, minus 4 times minus 2 gives me minus 8. And the minus and minus will give you plus. So 27 plus 8, that gives you 35. Going to the next, looking for a determinant also. Main diagonal 18 times minus 3 minus 4 times 0. 18 times minus 3 gives you minus 54. Then minus 4 times 0 is 0. Minus 54 minus 0 gives you minus 54. So that being said, we can now go start some simultaneous equation by matrix method. Please take note, other methods of solving simultaneous equation is elimination and substitution with graphical. So we have methods of dealing with simultaneous equation. We have elimination. Probably after we are done with understanding metrics, we'll touch this method. Elimination, we have substitution, we have graphical. Yes, very important one. Graphical. So this is the fourth method. Question 1. X plus 3y equal to 7. X plus 2y equal to 5. First of all, check if they are aligned. That is, if the x are on one side, then the y are on one side. So the x, they are all on this, the y, they are all on this, and then the constant, you have it there. So I'm going to transpose, change it now to matrix. It gives me, what's the coefficient? So you check the coefficients, the coefficient of each of them. Coefficient of x is 1, coefficient of x is 1, coefficient of y is 3, coefficient of y is 2. So that forms a square matrix equal to 7 and 5. I hope you understand what I'm saying. You check the coefficients and then you bring them out there. Having done that, you go on to solve. We're going to take the first determinant. The first determinant is going to be of the main matrix 1, 3, 1, 2. And then we'll go for the second determinant, but this time an determinant of x. In this case, the guys that are coefficient of x, which is 1 and 1, must be replaced with your constant 7 and 5. Then your matrix remains the same. Huh? Simply put, 1 and 1, 7 and 5. Just in case you don't understand, let's try it again. Now, I'm going to write the matrix the way it ought to be. This is 1, 1, 3, 5, 3, 2. So 1, 1, 3, 2. For the normal determinants, you put the whole matrix. For the determinant of x is the first terms. Remove it and put 7 and 5. That's what I'm saying. Then y is the second term. Remove it and put what? 7 and 5. That's how it works. Then you go find the determinants. Of course, now it's going to be clear. Main diagonal 1 times 2 minus the other diagonal 1 times 3. 1 times 2 gives you 2 minus 1 times 3 gives you 3. That gives you minus 1. That being said, the next main diagonal 7 times 2 minus the other diagonal 5 times 3. 7 times 2 is 14 minus 5 times 3 is 15. That gives you minus 1. Okay. The last 5 times 1 minus 7 times 1. 5 times 1 gives you 5. 7 times 1 gives you 7. So that gives you minus 2. So what's going to be my answer for x? My answer for x is determinant of x over determinant. My answer for y is determinant of y over determinant. So what's the determinant of x? Minus 1 over your determinant minus 1. Determinant of x is minus 1. Determinant is minus 1. When you divide, you get 1. Determinant of y is minus 2. Determinant of our determinant is minus 1. Divide, you get 2. So it means your answer for x is 1 and y is 2. Please always confirm if you are correct. How do we confirm? If I take my equation now, x plus 3y equals to 4, x plus 3y equal to 7. Sorry. What is our x in our answer? 1. 1 plus 3 times, what's your y? 2 equals to 7. 3 times 2, 6 plus 1. Is it 7? Yes. If that's the case, then you are correct. So moving on now to question 3 there. It says 2x minus y is equal to plus 7 equals to 0. So please watch it. Question 3 there says 2x minus y plus 7 equal to 0. Then 2x minus 3y equal to 0. If you notice here, your x is in one line, your y in one line, but your 0 is not in one line with this. So because equality sign is here, equality sign is here. So you have to make this first equation look like this. And how do we do so? You move your 7 over to the right hand side. You have 2x minus y, alright, is equal to 7 goes over, become minus 7. Then you have 2x minus 3y equal to 0. Now they are at the right part. So you translate it. You have 2, 2, that's the coefficient. Y, what is the coefficient? Minus 1. See? Y, what's the coefficient? Minus 3. Don't throw away the minus, so here you have minus 7 and 0. So let's go on. Our determinant will be the main matrix 2 minus 1, 2 minus 3. Our determinants of x, and determinants of y. So let me repeat everything. Minus 1, minus 3. Let me repeat everything there. Then for the determinant of x, x is the first term in your question, so you clean whatever you have as x. Determinant of y, clean whatever you have as y. The coefficient of y. Put your constant minus 7 and 0, minus 7 and 0, minus 7 and 0. Very simple. Now let's go for the determinants. Yeah, main diagonal 2 times minus 3 minus the other diagonal 2 times minus 1. So watch your signs very well. 2 times minus 3 is minus 6, minus 2 times minus 1 is minus 2. So minus 6 plus minus is plus 2. That gives you minus 4. That being said, we go to the second diagonal. What is the second diagonal? This is minus 7 minus 3. So minus 7 times minus 3 minus the other diagonal 0 times minus 1. Minus 7 times minus 3 minus and minus is plus. So 7 times 3 is 21 minus 0 times this is 0. When you subtract, you have 21. And here also the last diagonal 0 times 2 minus 7 times 2. When you multiply this, you have 0 minus this will give you minus 14. Okay, that gives you 0 plus 14, which is 14. Now let's check the value of x. X is determinant of x over determinant. What's determinant of x? 21. What is determinant? Minus 4. Nothing can divide, so your answer remains minus 21 over 4. What is your value of y? Determinant of y over determinant. What's the determinant of y? 14. What is your determinant? Minus 4. What can divide? 2 can divide. It gives me minus 7 over 2. And let's check if whatever we got is correct. So I'm going to put the first equation, which is 2x. This is to prove if we are correct. 2x minus y equal to minus 7. Let's put our value for x. 2 times, what's your x? 20 minus 21 over 4. Then minus your y. What is your y? Minus 7 over 2 gives me minus 7. Okay, let's clean the two parts so we can confirm very well our answer. So 2 times minus 21 over 4. 2 times minus 21 is minus 42 over 4. Minus minus is plus 7 over 2. That gives you minus 7. So let's add this fraction. LCM of 1 and 2 is 4. 4 divided 4 is 1. 1 times minus 42 is minus 42. Plus 2 divided 4 is 2. 2 times 7 is 14. So leave the right hand side first. Minus 42 plus 14. Obviously, it's going to give you minus. Remove 10 from 42, you have 30, 32. Then remove 2, you have 30. Then you have minus 28 over 4. Or when you divide it, you will get minus 7, which means our answers, they are very correct. So that being said, we'll be going to the next equation.